So I'm going to talk a little bit about heat pumps now, just for a minute. A fridge is a heat pump. It's something we're very familiar with. What a fridge does is it takes heat out of the box where you want to keep your food cool, and it raises the temperature and releases it into the room at the back of the fridge. You may have noticed it's warm at the back of the fridge. So the idea with using a heat pump to heat a building is that you can collect energy either from the air, just the air temperature, or from the ground, or from water. And you can take that energy and sort of concentrate it, raise the temperature, and use it for heating your building, heating a house, heating hot water as well. So you do that with a sort of compression expansion cycle, which is a bit complicated, but you have a gas that you squash, and when you squash a gas it gets hot. When you let it expand, it takes energy to do that, so it cools at that point. So you put the cold bit into the resource you want to collect energy from. So the air or the water or the ground warms up that cooled bit. So you get some energy from that, then you squash it and compress and get more energy out of the system. So you move heat from one place to another and make it at a higher temperature and useful for heating a building. And it's worth saying that we tend to think of cold objects, say sort of 0 to 10 degrees, as not having much energy. You don't like them, do we? They feel horrible. But it's not true, actually. At 0 degrees, the same object has 93% of the energy as the same object at 20 degrees. Have you heard of absolute zero of temperature, the Kelvin scale? Yeah. So that little difference in temperature doesn't make that much difference. There's quite a big resource, even of something that feels quite cold to us. So the overall sort of energy flow or power flow for a heat pump, you do need some electricity to run it. This is an example of a fairly small heat pump. So you put some electricity in, maybe a kilowatt in this case, and you collect, for example, 2.5 kilowatts from the ground, and the total output you get, in this case, is 3.5 kilowatts. So the electrical input and the heat input end up as heat output. So you're taking some electricity and you're ending up with 3.5 times, in this case, the amount of energy you started with, that you've collected from the local environment. So it's a sort of way of extending the energy you've got, the electrical energy. And there's a thing called the coefficient of performance, which is the heat output, which includes the electrical input, divided by the electrical input. And that's the important sort of parameter, really. That's how much extra you get out compared to what you put in. Okay? In this case, that's a COP of about 3.5. So it sounds great. It sounds like you're getting lots of free energy from where you are. But if we just look at the next slide, at the moment, most of our electricity comes from fossil fuel power stations, and those power stations are very inefficient. They're only about sort of 35 to 40% efficient. So at the moment, if we look at running a heat pump from a fossil fuel source, we burn a fossil fuel, we end up with about 30% of it, a third of it left, and then we get a third back, 3 times back from our local environment. So that doesn't make very much sense environmentally unless we can get more back here than we put in. I mean, compared to purely electric heating, it's 3 or 4 times better. It's a lot better. But what we really want to do is run heat pumps from a renewable source. If you've got clean electricity, then it's fantastic. It just extends the amount of use you can do with that energy. So there's sort of tie-up here, thinking of running a wind turbine and a heat pump for this building. Most of the electricity from the wind turbine could be used to run the heat pump, and then you get 3 or 4 times the amount of energy, the benefit from that. And also, when it's windiest in the winter is when you most need the heating. So that could be a really nice tie-up. And also with the renewable heat incentives that are being talked about, you'd then be paid for that clean heat that you've generated, environmentally friendly heat as well. So there could be lots of cost benefits there. Could be a really nice tie-up for that. A little bit of physics again. I'm going to stop very soon. This is how the sort of theoretical efficiency of a heat pump depends on the source temperature, so where you're getting your energy from, so the ground or the air or whatever, depends how warm that is, and how hot. So these different lines here are for different outlet temperatures. So if you're running radiators at quite a high temperature, say 75, 80 degrees, then the efficiency is much lower. If you can use the output at a low temperature, sort of 35, 40 degrees, underfloor heating, which you've got here, you see how much more efficient the heat pump can become. So you want to try and make sure you've got the highest source temperature and the coolest outlet, and then you get a more efficient installation. So again, that's a nice tie-up. The fact that you've got underfloor heating here already is a good way of doing it. Next slide. Yes, so the local heat comes from various different places. On the whole, usually a water source heat pump can be the most efficient, because water stores a lot of energy and it has good thermal conductivity as well. And then ground source is the next most efficient, and then air source least efficient. But it does depend on the climate and the way they're installed as well. And your climate is relatively unusual here, because you've got the Gulf Stream coming in, and you've got relatively mild winters. So an air source heat pump is actually pretty efficient here. And it's usually easier and cheaper to install as well. So it does depend where you are. Installed cost for the heat pump itself, approximately £10,000, but again, that's not your money. Using a heat pump is far better than just purely electric heating, because you get 3 or 4 times the output. And if you can run it off renewables as well, as you might be able to here largely, then it's zero carbon. It's clean, it's sustainable, it's great. And there's the renewable heat incentive coming in the next year or so, which would get you extra payments from having done that. This is a picture of a heat pump installation that we've got at TAT, which is a water source heat pump. It looks a little bit like a big box, maybe a little bit like a freezer, something like that. I'm nearly done now. There you are, completely done. All right, thank you.